Dr. Sneha Mishra, Assistant Professor, Department of Computer Science and Engineering, AKGEC, Ghaziabad. So, I'll be teaching machine learning techniques. In the previous lecture, we have discussed about the machine learning, few of the machine learning approaches. From today, we'll be having the discussion on decision tree learning approach. So, in decision tree, since it is a supervised learning approach, we use both classification and regression to split the data set into subsets based on the feature values, and it is resulting in the tree structure, like we have branches to represent the decisions and nodes. So, there are three things: nodes, branches and leaf nodes. Nodes are the points at which the data is split, branches are the outcomes of the decision made at the nodes, and leaf node is the terminal node that contains the final output, like the whatever we want to classify, that will be the leaf node. So, this is the tree structure you can see. So, how it works, that the algorithm select the feature that best splits the data, then it creates the branches based on the outcomes of the feature, then the process continues until the data point is classified. So, here you can see in the diagram that we have the root node, that is the decision node. Then we have the subtrees also here, there also there are decision nodes, and the leaf node is classifying the based on the decision. So, the popular algorithms which we use in decision tree are classification and regression trees, and there are applications like medical diagnosis, customer retention. So, in medical diagnosis, what we are doing is we are predicting whether the patient has a disease, and how we are predicting based on the symptoms. So, and also there is another example, that is customer retention. So, how we are doing this customer retention? We are predicting whether the customer is will churn based on the past behavior. So, this is the decision tree learning approach. Now comes the Bayesian network. So, in Bayesian network, there are probabilistic graphical models that represent the variables and their conditional dependencies by directed acyclic graphs. They are used to compute the probabilities of various outcomes. So, here also there are nodes, there are edges, there are conditional probabilities. How is it different from the decision tree? Actually, in decision tree we have a node, then we have decision branches, and we are classifying that according to those decisions. In Bayesian network also we have nodes, we have edges, but the decision is based on the conditional probability, that is representing the likelihood of the event based on the given state and the another event. So, the edges here indicate the conditional dependencies between the variables, and the nodes represent the random variables. So, how it works? It defines the network structure based on the variable dependency, then it assigns the conditional probability to each node, then use the inference algorithm to compute the probability of unknown variable given evidence. So, again the applications may be in medical diagnosis, like to predict the probability of diseases according to the given symptoms, then spam filtering, like classifying the email whether they are spam or not. Right, and the algorithm which we use is the popular algorithm, that is Naive Bayes classifier. The another approach is the machine learning approach is support vector machine. So, in this again it is supervised learning model used for classification and regression, and it find the hyperplane that best separates the data into different classes. So, here the key concepts are hyperplane, support vector and margin. In hyperplane we are what we are doing is there is a boundary that is separating the classes. Support vectors are the data points that are closest to the hyperplane, and the margin is the distance between the hyperplane and the nearest data point. So, how it works? The support vector machine plots the data points in an n-dimensional space where n is the number of features. Then it defines the hyperplane that maximizes the margin between the classes. Then the data points near the boundary, which is support vectors, are used to define the hyperplane. The applications of support vector machine are text categorization, in which we are classifying the documents into predefined categories, or we can say image recognition, in which we are identifying the objects in the image. The another approach is genetic algorithm approach. It is the optimization technique inspired by the process of natural selection. It is used to find the approximate solution to complex optimization problems by mimicking the biological evolution. So here the things are like chromosomes, fitness function, crossover and mutation. Chromosome is a possible solution of the problem. Fitness function measures how close a given solution is to the optimal solution, and crossover and mutation are the operations that combine or alter the chromosomes to create the new solutions. So how it works, it generates a random population of the solution, then it evaluates the fitness of each solution, then selects the best solution and apply the crossover and mutation to create the new generation. And this step is repeated until the optimal or satisfactory solution is founded. So this is how the genetic algorithm works. So the applications of genetic algorithm are scheduling problems like optimization tasks, schedules in factories, then game development, creating AI players that evolve to improve the gaming strategies. So in game development and scheduling problems, we can use genetic algorithm. So here I want to summarize the machine learning approaches. So we have artificial neural network, clustering, reinforcement, decision tree, Bayesian network, support vector machine, genetic algorithm. These were the approaches. I think these are the 7 approaches. So the focus of these approaches was different for different approach. Like in ANN, the focus was pattern recognition. Algorithm which we used was backpropagation, CNN, RNN. Applications were for image or voice recognition or NLP, natural language processing. Then in clustering, the focus was grouping the similar data. The algorithm which can be used is k-means or hierarchical clustering. Application was market segmentation or anomaly detection. Then the reinforcement learning approach, the focus was learning by interaction. The algorithm were Q learning and DQ learning, deep Q network actually, and the applications were gaming, AI and robotics. Then decision tree learning, it is the rule based classification. The algorithm which is used is classification and regression task. The applications were medical diagnosis and customer churn. Then the approach Bayesian network, the key focus was probabilistic inference. Popular algorithm was Naive based and Bayesian inference. Then the applications were spam filtering and medical prediction. In support vector machine approach, we used the classification and algorithm was SVM again, and the applications were text classification. In genetic algorithm, we were doing optimization and it is genetic algorithm only, and the examples were gaming, AI and I think this was scheduling problems. So what are the issues in machine learning? When we are implementing machine learning models, various challenges arise that can affect the performance, that can affect the accuracy and reliability of the model also. So as per such things, we can say that there are issues also in machine learning, like data quality and availability. If we have missing data, incomplete data, like we have latency in the data, or we have noisy data, we have imbalanced data, we have skewed data distribution. So such are the problems of either the data quality or the unavailability of data, or the data is not in the proper format which we have, which in the format which we require. So garbage in, garbage out. The success of machine learning heavily depends on the quality and amount of the data available. And if this is the issue, that we are having the latency of data, we are having a noisy data, we are having imbalanced data. So this is the very primary issue in machine learning. So how we can Like example can be the healthcare data. In healthcare, the medical records often have missing values such as incomplete patient history, so which can reduce the reliability of the disease prediction model, right? So how can we solve these approaches? We can do data cleaning, like we can remove or impute the missing values and handle outliers. Then we can do data augmentation, like using the techniques to generate the synthetic data or resample the existing data to balance the classes. Next is overfitting and underfitting. Again, this is the model learns the training data too well. If I talk about overfitting, so in this the model learns the training data too well, capturing noise and outliers, but fails to generalize the new data. And underfitting, the model is too simple to capture the underlying patterns in the data, leading to poor performance both in training as well as in test sets. So what is the solution for overfitting? It is to use the regularizing technique and also apply the cross validation to evaluate the model performance, then simplify the model, reduce the complexity or prune decision trees. And for underfitting, we can use the complex models, add more features to improve model capacity. So as example, we can take that overfitting in stock market prediction. A model that is highly tuned to the historical stock market data might fail to predict the future trends due to the market volatility and random events, right? And third issue is high dimensionality. As the number of features or dimensions increases, the complexity of the model increases, leading to the potential performance issues. This is also known as curse of dimensionality. So too many features can dilute the importance of the relevant variables, leading to the poor model performance. So what is the solution for this? Like we have the dimensionality reduction. So we can use PCA to reduce the feature space. So PCA is the principal component analysis. So feature selection, identify and retain only the most important features used to using methods like mutual information or correlation analysis. So if we take an example, in text analysis, high dimensional data sets with thousands of words may overwhelm the model. So using the technique like TF-IDF or word embedding can reduce the dimensionality. Then the fourth issue is bias and fairness. So bias in data is machine learning model can inherit biases present in the data, leading to discriminality or unfair outcomes. So the bias in algorithm, the design of the algorithm itself can introduce biases. So what are the challenges? So bias model can lead to ethical concerns, especially in the area of hiring, leading or criminal justice. So what can be the solution for this approach is we have to first of all detect the bias. So use the fairness matrix to measure or access the bias. Then we have to do the debiasing, like applying the techniques like reweighting and resampling to correct the biased data. Then implement fairness aware machine learning algorithms. The example of this is hiring algorithm. A model trained on historical hiring data may favor the certain demographics, even others over others, leading to the biased hiring decisions. Next issue is model deployment and maintenance. So in model deployment and maintenance, moving from the development phase to the production introduces challenges such as model integration, updating and maintaining the performance over time. So the challenges are data drift, versioning. So what is data drift? It is underlying data distribution may change over time, making the model obsolete, and versioning is keep tracking of model updates and ensuring the backward compatibility. The solution approaches are model monitoring, then A/B testing, so test new model version before the full scale deployment. Then the example can be that like an e-commerce company may deploy a recommendation engine, but as user behavior evolves, the model may need periodic retraining and updates to stay relevant. Next is scalability issue. In scalability issue, as data grows, model needs to process vast amount of data efficiently. Machine learning algorithms, especially deep learning models, can be resource intensive. So the challenge comes here, like processing time and memory usage can become bottlenecks as the size of the dataset increases. So distributed data storage and computation might be required for large datasets. So what can be the solution for this is like parallel computing, optimization technique, or cloud based solutions. We can use this, and example can be like training a deep learning model on billions of images or millions of images for object detection, as example Google Images. So require immense computational resources and distributed system. So we can have this issue. Next, we can have ethical or legal concerns. Like in machine learning models, particularly in sensitive areas, can raise ethical issues such as privacy violations, misuse of data, or unintended consequences. So the challenge can be of the privacy, handling sensitive data, like as example we can say the healthcare or finance information, while maintaining the user privacy. And ethical decision making can be avoiding harm or unfair treatment of certain individuals or groups due to biased model. So the solution can be privacy preserving techniques, ethical guidelines, legal compliances, and as an example we can take a facial recognition technology that are ongoing debates, or privacy surveillance and misuse of law enforcement agencies. So thank you.